So, a couple things off the top. I went in, every kind of absence that could be excused was kind of identified as excused in here. And then I took your lowest 3 iClicker scores and I dropped those. So this iClicker grade that's showing up now should reflect kind of what your final iClicker grade score will be with the lowest 3 dropped. I'll do a similar thing for the Excel and Connect assignments once kind of all those due dates are passed. So you'll see a similar kind of category show up for each one of those that shows you what your grade is with the lowest drop. Maybe even before I leave today, if not for sure tomorrow, I'll do a similar thing for the Learn Smart since we won't have any more of those, kind of showing you what your score is with the lowest dropped. You can then use this file that I put up, which is called what? Figure out your grade. So we'll download this here real quick. There we go. So the way that you'll kind of use this is once I guess currently you can use whatever your current grade is in that Connect category. But, once the due date's passed for all of them, you will eventually use your Connect grade with the lowest dropped. And you can kind of play around with what score you in the final to get different grades. So this is like a hypothetical person. So whatever you had for your kind of Excel category grade, kind of across all the assignments, you would put that in here. That iClicker grade that shows up with the lowest 3 drop, put that in here, so on and so forth. You'd put in your 2 exam scores. And then for like this person, they could play around with, okay, I want to make sure I'm getting a C minus or at least a C minus in the class. How low could I score in the final and still get that? Well, you can start playing around with, what if this person got, oh, I didn't hit the, again. Save. You could play around with, I'll show you how it works. For this time, I need to make sure that I select enable. There we go. So I can say, okay, how low could I score and still get a 70? If I get a 40, even if I get a 30, okay, I just need to make sure I score, above a 20 on this exam, or 25, whatever it ends up exactly being. Kind of make sure that you can get whoever kind of targeted grade you want. So it'd be nice to have this. You can kind of create this for any class that has weights. So all I did here was factor in how much each one of those categories is weighted, right? Based off of the syllabus. And you can kind of play around with that final exam score you need. And then you can kind of allocate your time resources to whatever classes, doing well in the final would help your grade out the most. But yeah, so this should be kind of useful as we're going into the final. Any questions over anything kind of related to what was just mentioned here? Okay. So let me minimize all this. And I have these lecture slides up on Canvas as well. So we're going to do a little bit more linear regression today, just see more examples. So one of the examples that I'll show you is kind of this paper that really kind of pushes it. I think what we have done in this class, we can understand it, but you could push it even further, right? So I'll give you kind of a glimpse of what it looks like and how do you take this regression analysis and apply it to some real world issues, okay? So, if we remember kind of our general interpretation for our coefficients is it's a 1 unit increase in our X variable causes the predicted value of Y to change by whatever that coefficient estimate is. Okay? And then with multiple linear regression, it's the same thing. We just add in holding everything else that we included on that right-hand side constant. All right, so it gives us a lot more power. So I'll kind of give this broad kind of idea. I had some interest in it at one point. There's a lot of, I shouldn't say a lot, there's some work out there that's been done on it. But we'll kind of look at, like, based on the data we have, kind of what our conclusions would be related to kind of athletic success and kind of athletic expenditures. So what I'm thinking about here, and hopefully by the time we get to it, we'll realize this isn't just about a university's athletic department or sports, performance. So what we're going to try to estimate is whether or not a team makes that first round of the NCAA basketball tournament. Okay. So, you know, if you're not a sports fan, right, this NCAA tournament is this massive event. There's what, 60, not 4 teams anymore. They've added a couple. So 68, I think. Yeah. And we're going to say, okay, what's the impact of expenditures on my basketball program on my on whether or not I make the NCAA tournament. So one thing we haven't looked at yet is what happens if the dependent variable we have is just a 1-0 variable. Well, before we said it's a 1 unit change in our x variable causes the predicted y to go up by whatever our coefficient estimate is for b. But y was always in units. This was like the dollar increase or the grams increase in birth weight, you know, all these different types of examples. Well, now that our dependent variable is 1-0, the coefficient reflects the change in the probability that I go from a 1 or a 0 to a 1, right? So now this would be the effect of a $1 increase would have this impact on the probability of making it in that first round in the tournament, right? Or making it as one of the top 68 teams. Okay. So it's a little bit different. It's just that the reason why we can now say it's an increase or a decrease in the probability is because that's the units of a 1-0 variable, right? We're thinking about what's the probability changes of going from 0 to 1, not making it into the tournament to being in the tournament. So you can imagine athletic departments are probably pretty interested in this question. And we'll show why not just the athletic department will be interested in it once we get kind of through this entire example. But for now, this is just if I spend one more additional dollar on my basketball program, what's the change in the probability that I go from not making it to making it into that tournament? So if you had to say like what you would expect the sign and the size of that coefficient to be, which of the following would you think would that be? So first of all, what would you expect the sign to be? Schools that are spending more money on their programs are, likely increase their probability. Right? So probably positive. And then remember the unit here, it's just a $1 increase. So what would you expect the size of that coefficient to be? Small. Really, really small, right? Now, it doesn't ultimately matter because if I know the effect of a $1 increase, to get the effect of a $1,000 increase, I just multiply it by 1,000. But in terms of the actual coefficient we'll see, it's going to be relatively small. So we also had this discussion last class, which is if there's other variables that matter other than just basketball expenditures on the probability of whether or not I make it into this tournament, if I don't include those, I'm going to have this bias component that's part of that coefficient estimate that I see. Okay. So if I think about something like total number of undergraduates, we could probably put a sign on what that bias is going to be based off the relationship between that omitted variable and our x and y. Now, I'm not going to expect you to know this. I was using these slides for multiple classes, one of which I expect them to know how to kind of be able to buy it or put a sign to this bias. But for us, all we need to know is that that bias would exist if we didn't include that total number of undergraduates, right? Because likely larger schools are just going to be spending more money on all of their athletic programs, not just basketball. Okay. So we want to control for that. So if we looked at the results, if we ran that real simple kind of naive regression with no controls, it does look like there's a positive impact. Oh, it's very small, right? 0.0000008. So a very small coefficient, which is what we expected. It's just a $1 increase. However, that p-value is basically 0, which means that for that coefficient, we always start out with a null hypothesis that is equal to 0. I then just found a p-value that was approximately 0. So it's going to be less than any level of significance I want to do or any level of confidence, right? 0 is going to be less than any alpha value. So I can reject the null, or really what I'm rejecting is that there's no relationship between basketball expenditures and whether or not that team makes the tournament, which makes sense. I mean, I would think, it's not surprising that we can reject this norm. Okay. Any questions over anything up to this point? Okay with everything here? All right. So I then include the number of undergraduates to try to kind of control for the size of the university. Now I notice that does change my coefficient a little bit. It's gotten smaller, but it's still very significant, right? So what if I wanted to interpret this coefficient now? Well, now it'll be the effect of spending $1 more on my basketball program. It would be change the probability I make the tournament by 0.0000007, right? But that's the effect of just $1, holding everything else constant. So here, holding constant the number of undergraduates, okay? So it has a little bit more power behind that statement, behind that interpretation of my coefficient, okay? Now, just including, the team expenses, my R squared was 0.17. So I was just with that one variable explaining 17% of the variation that exists in whether or not a team makes it into that first round of the NCAA tournament. When I included number of undergraduates, notice it didn't change my R squared much. It did increase it some, but it looks like the number of undergraduates isn't the most influential thing or isn't the most useful variable when it comes to predicting whether or not a team makes it. And this kind of makes sense. So there's a lot of small schools that make it in the tournament. And so it may not be that these two things are really that correlated. Right? But there's probably other things that would matter, right? So, well, I guess I jumped the gun a little bit here, but we can add in additional controls if we really wanted to. Okay. Before I do that, we'll start to think about how can I use this coefficient to start to make some more interesting kind of thought experiments. So if this is the effect of $1, right? Well, it seems relatively small, but teams aren't spending tens of dollars on their program. In fact, if we look at the data, they're spending millions, right? The average is 1.3 million, but there's a pretty large standard deviation, and we see the range goes all the way up to almost $23 million. So, $1 is pretty insignificant, right? We might see teams increasing their expenditures by hundreds of thousands of dollars. So what we're going to do is think about, if I looked at the schools within the top 100, right, in terms of the teams spending the most amount of money on their basketball program, if they were to increase their budget by 10%, that would be about a $935,000 increase. Now, a 10% increase in your budget is a pretty large increase, right? However, I mean, if you think, making the tournament, I shouldn't say teams, conferences are actually given money and then they split it up with the teams. So there are some revenues that could compensate you for that. So what would the effect of a $935,000 increase be? Well, we would just take that coefficient and multiply it by 935,000. So you get that for these schools in the top 100, on average, if they increase their budget by 10%, they would increase the probability they make that tournament by 0.069 or increase their chances by 6.9%, right? Just kind of converting that decimal, that proportion into a percentage there. Okay. You could do this for specific schools. So like IU is spending a little bit above the average in the top 100. If they increase their budget by 10%, it would be 1.2 million. So the 10% increase in their budget there, you take the effect of $1, multiply it by $1.2 million, and they would increase their probability of making a turn by about 0.08, right, or 8.8%. So this is just like how once we have that regression output, how we can use those coefficients to start to think about what the impact of different decisions would be. I then did Ball State. The 10% increase for them is 150,000. So right, if we say if they increase their budget by 10%, well, they're only increasing their probability of making the turn by about 0.01. Right? And you could do this for any school, any amount of increase in their budget. But this is just kind of a quick little look into it. Right? So what might we also want to control for? Well, I probably want to have some measure of what's the general historical quality of this team. So I'm going to try to control for the quality that the team was prior to this change in expenditures. So I'm going to use previous tournament appearance and previous number of wins, right? The wins from the previous season to kind of look at, well, what was their performance the previous year, right? To kind of control for that. I'm then going to look at, well, what's the revenues that they're generating, right? Because teams with high expenses, well, they might have high expenses because those expenses are leading to them being able to generate higher amounts of revenue as well. So I'll control for that. I'm then going to do something that I don't think we've looked at yet, and we usually call this fixed effects. But what I'm going to do is if I were to run a regression, and let's say I wanted to look at the impact of year. This might seem kind of goofy at first, but I'm just using this to kind of illustrate what we're doing. So our y variable is making it round 1. What we're going to do if we include the variable year on the right-hand side is we would force there to be a linear trend across time. Okay. Well, we don't want to force that relationship to be kind of linear, because it could be that if we look at the actual data, right, maybe year by year, it's jumping all over the place. It's not following a functional form. So one way we can capture this is instead of just including the variable year, we'll include, was the year 2020? So there would be a 1-0 indicator for that. Add in another one, which is, was the observation in 2019? And include an indicator variable for every single year. Now we'd have to leave out the earliest year so that we would have kind of a comparison, right? The effect on the probability of making the tournament, if we're thinking about the observation being in year 2020 relative to whatever that first year that we left out was, right? But we'll include indicator variables for all those years, and then that way we don't force there to be this linear relationship. So, and things change year to year. Different policies, maybe there's some rule changes, like slight rule changes. Maybe there's a higher quality of opponents, things like that. So we'll include those as well. And now my regression output looks something like this, right? So I've got all these other controls, and I can look at what's the effect of basketball expenditures. Now, this has fallen quite a bit. Before it was what, 7 point something to the, move that decimal point 8 places to the left. Now it's only 2.3. So it's fallen quite a bit in size. However, that p-value is 0.001, so it's still significant at every single level here, right? That p-value is less than alpha at every level. So we can reject this null hypothesis, reject that there's no relationship, or say, we found evidence there is a significant relationship between basketball expenditures and making it into the tournament. Okay. So the thought experiment becomes a lot more powerful here, because now the way we would interpret this coefficient is 2 schools who either both previously made the tournament or not, had the same number of total undergraduates, generating the same revenue, had the same number of previous wins, and we're looking at them within the same year, but one of them spends $1 more on their basketball program. What's the change in the probability to make the tournament, right? So as we add in more control variables, what we're saying has a lot more power. We're holding constant more and more factors, okay? Excuse me. So if I'm looking through here, I can very quickly go and say, okay, look, what variables here are significant? All right, what variables can we reject the null for? And let's just say at the 90% level, so alpha of 0.1. Well, I go through here, well, total undergraduates, I can't say that relationship is anything different from 0 once I include all these other control variables. I can reject the null for previous tournament appearance, expenditures, revenues, previous number of wins. It looks like these earlier years, they didn't really give me any predictive power, but in the later years of data I had, it looks like making sure I'm controlling for what year I'm in is really important from years 2008 to 2012. This is a little bit older data. It wasn't quite as new. This expenditure, revenues, and some other variables we use aren't made available until a couple of years after the fact. Okay. Any questions over anything here before we keep moving? Okay. So, you could do the same sort of thing for whether or not the team made the national championship, like whether or not they won. Now, I'm not going to spend a whole lot of time here. It's pretty much the exact same thing, right? We just changed our dependent variable from being the probability you make it to the tournament to the probability you win the national championship. Now, whoops. Oh, did I not have? This might be an old one. Let me open the file that I put up here, because I know this one has. Does this have the other slides in there? Maybe not. Let me see. Oh yeah. Yep. Here we go. I don't know why that one I accidentally deleted them earlier. So where did we just leave off? Oh yeah, can you buy the championship, right? So, you know, these are interesting questions, but like, especially if I don't care about sports, why, like, what's the point of this? Well, one thing that they've kind of has been shown is that having some athletic success, specifically this NCAA tournament, I mean, these brackets go around everywhere. People who aren't even interested in sports bet on it, fill these out. It's kind of like this, I don't want to say it's a holiday, but it's damn near close to it, right? So these schools that otherwise people might not have heard of, their name gets out there a lot, right? So I always use the example of, if you're from Indiana, maybe you do, maybe you don't, but you're more likely to know that where Valparaiso University is, or the fact that it exists and is within the state. If I'm from California, all bets are off if they have any idea that there's a university called Valparaiso University, right? So if Valparaiso makes it into that tournament, they're almost like getting free marketing, right? They're getting their name out there. Now, it's not free. Yes, they paid to have this basketball program, but, right, there is going to be this benefit of making the tournament to where just getting your name out there. Maybe more students look into the university, become more aware that it exists, and they end up finding, oh, this is actually a pretty good university, it has some decent programs. Like, I think I might want to, apply here. Right? So maybe there's some like unintended consequences of having this tournament success, or having, success in my basketball program. So the next thing that we're going to look at is, does this success impact the number of applications that a school receives, right? So now, one thing we're going to have to do is we're going to have to look ahead. So if they had success in spring of 2021, that's not going to have an impact on applications until the following school year, right? So we're always going to be using kind of the previous year's success in the tournament. So what I'm going to look at here is my Y variable, we're going to use as applications, and my X variable is just, did I make the tournament in the previous year? So I'm thinking about, how do I interpret my coefficient now? Well, now my Y variable actually has units, right? It's the number of students that applied, or potential students. And now my dependent variable, not dependent, now my independent variable is whether or not they made the tournament in the previous year. So now this is just a 1-0 variable. So the 1 unit increase in my X variable is just going from the group that was coded as 0 to the group that's coded as a 1. So starting with not making the tournament, if a team instead made the tournament in the previous year, the expected change in the number of applications that school receives will be whatever our coefficient estimate is. Okay. So we'll take a look at that. So it looks like this is huge, right? It looks like making the tournament the year prior increases applications by about 7,000. This just seems absurd. Well, it's because we haven't controlled for anything else, right? What do you think is probably true about, larger schools, larger programs tend to have a higher likelihood of making it into the tournament. So they're automatically going to be where we would expect them to have a higher number of applications. So we want to somehow control for where these universities' applications were starting out prior to the success. So one way we can do this, and a real good way to control for differences across our observations in terms of where they start out. For example, here, our university is going to start out with different enrollments or kind of baseline applications, is just include the previous year's applications. So that way, now the interpretation of our coefficient on whether or not they made the tournament in the prior year is holding constant the number of applications from the previous year, So two schools were getting the same number of applications last year, but last year, one of them made the tournament. We would expect that university receives on average about 101 additional applications. Now, it's not quite significant, right? Our p-value is 0.135, so we just barely fail to reject the null. Well, if we fail to reject the null, we can't actually say that there's any significant relationship between previously making the tournament and the number of applications. So, it's not great, right? We can't quite say that with 90, 95, or 99% confidence. However, I shouldn't completely dismiss it, because what level of confidence could I reject that null at? Looks like here, what, 86? Is 86 that much worse than 90%? I'd argue no, right? But we have to draw some cutoffs, some benchmarks somewhere. So this one wouldn't quite we couldn't quite reject the null at our conventional benchmark values, but it still is evidence that shouldn't be ignored. Right? And also, I haven't included a lot of other control variables. So one thing I'll do here is similar to how I threw in year fixed effects before. You can also include things like state fixed effects. So I just created indicator variables for every single state and said, okay, if this observation was in Indiana, put a 1, 0 if not. And then have another indicator variable. Put a 1 in this indicator variable if the observation was in Michigan, 0 if not. Then put a 1 in and do that for every single state. Right? So what I'm able to do there is say, holding constant the state I'm in, so two universities that are within the same state have the same number of previous applications, but one of them made a tournament, we would expect them to see about 167 additional applications. Okay. And we could do some other fancy stuff to think about this as what's the percent increase in applications for universities of a certain size. But here we're at least picking up there is some positive increase in number of applications these schools are receiving. And here, once we control for the state, it's significant at what? The 10 and 5% significance levels, or 90 and 95% confidence levels. Okay. So it looks like there's some kind of indirect positive impacts of this athletic success. Right? Sorry, what else? Is there anything else I want to say? Oh, also notice in my R squared, I'm explaining 97% of the variation that exists in this variable. So I'm not near as concerned with omitted variable bias here. There's a very little amount that I haven't explained. So if these schools are receiving a higher number of applications, let's just assume for a second they didn't want to change their enrollment, but they're getting more applications, right? What's going to happen to their incoming freshman class? What might you expect to happen? Well, let's say they want to hold constant the number of people they admit. What's a characteristic about that class? Yeah, right. They can be more selective. Now, how do we measure this? Could it be like some performance metric, or whether they're more likely to be retained or graduate? We could measure this in a bunch of different ways. But one thing that all these universities have to report is what their incoming freshman class's ACT, SAT score is. Now, this has fallen out of the wayside a little bit in more recent years because not every university is requiring it, but this data is a little bit older, and so we have it for the majority of universities that were in this data. So they report not their mean ACT scores, they actually report the 25th and 75th percentile, but it's still a measure of, am I shifting that distribution to the left or the right? Now, we would think it shifts to the right, that it can be more selective. So, the 75th percentile of their incoming freshman class should go up a little bit. So we're going to use the math ACT score first. We could have maybe added the English and the math together, but we can also kind of look at them separately. So here, just to not muddy up, make these huge tables, I didn't include the states. If you do, it's a very similar effect. So it's not wildly different. But now we can interpret the coefficient on previous tournament. Sorry, I pointed the wrong one. Previous tournament, right? Were they in the tournament in the prior year or not? If they were, holding constant the number of previous applications, we would expect their 75th percentile of their incoming freshman class's ACT math score to go up by 1.5 points, which may not sound like much, but if you really think about it, that's a pretty sizable increase when you're just taught, like if you want to think about it as the average ACT score went up by that much, that's pretty big shift for the average of your entire student, freshman student body. Right? So success in the previous tournament not only leads to a high number of applications, but it looks like schools are able to be a little bit more selective, or maybe, and we don't have a way to specifically measure this, maybe they're getting better applications, right? Maybe these additional applications are higher quality students. You can't necessarily say one way or the other, but whatever the mechanism, it looks like it's generating a higher quality kind of incoming freshman class. And we can definitely reject that relationship is zero because our p-value is going to be less than any alpha. We can do the same thing for the English ACTs, and you see kind of a similar increase, right? 1.8 point kind of shift to the right. You could do, I think I showed math twice here. I didn't mean to do that. So how great are these effects? 1.5, 1.8 kind of point shifts. Well, the standard deviation is about 3.5. So we're talking about half a standard deviation, a little more or a little less in kind of the math side of things. But it's still like a pretty good shift, right? We're still getting a pretty sizable effect. Right? So, if we think about it, the kind of totality, we could use linear regression to understand like this broader, like multiple connected questions. If I spend more money on my basketball program, can I change the likelihood that I make it into this tournament? We saw that yes, you can. So if I spend some additional dollars, I'm more likely to make it in the tournament. Well, now that I'm in the tournament, what impacts would that have kind of moving forward? It looks like it'll increase the number of applications potentially received and also allow you to be a little more picky or you're getting higher quality applicants and kind of increase that freshman class's kind of overall average quality. Right? And a university would care about this, right? Like that's things they could put on their pamphlet that, now they've got this higher kind of S8 or ACT score for the freshman class. So when you're weighing out kind of all the costs and benefits as a university to how much you're spending on different sports programs, all these kind of indirect effects would need to be taken into consideration as well. It's not just the revenue generated from your athletic department. Having a better incoming freshman class, I mean, this could have a snowball effect, right? It could lead to a higher number of applications the following year and a higher incoming freshman class the following year, because you're able to kind of have a little bit, better numbers to put out in flyers or in kind of your website or however you're getting information about your university out there. Okay. So hopefully this kind of shows like this regression analysis is pretty powerful, allows us to kind of make some pretty big statements and understand and make some optimal decisions about kind of future, make optimal future decisions, right? And actually have them grounded in some statistical analysis. Okay. Any questions over anything we've talked about to this point? You guys are the brave, the dedicated here today. Kind of knowing there wouldn't be eye clickers, just trying to kind of hear more of these, interpretations for linear regression, see more examples. I think it'll just, help it soak in just a little bit more. So I think that was the last thing I had there. I also put up on Canvas a couple PDFs. So we're going to look at this MML and fatalities one. Except for, I'm not going to do this. I have it in here. I don't want to open it in a web drive. So here, we'll download this. I want it to open up as a PDF. There we go. So I'll try to, make this as easy to understand as possible. This is an actual kind of peer-reviewed, currently this is a working paper, but it's been published since then. And it asks a pretty interesting question. So the way that I usually read papers, if you're not real familiar, if you go to like Google Scholar, you can search anything and it'll show you all the academic papers. So this one, I think what all I did was I searched marijuana legalization impacts and kind of looked at some of the papers that were out there. So usually when I open a paper, I'll read through the abstract to see kind of what was the general consensus. So what? They state here that using state level data, it looked like when medical marijuana became legal, it increased the use of marijuana among adults, but not minors. It was also associated with a 9% decrease in traffic fatalities. They found some evidence that it led to it had an impact on alcohol consumption, and that provide evidence that these marijuana and alcohol, these two goods, are substitutes. Okay. So we'll kind of walk through their results to then understand how they came up with these conclusions. So what they're essentially doing is they have all these different kind of things in mind. So the first was they had different levels or different measures of alcohol consumption. They then wanted to think about, okay, what was the impact on alcohol consumption in a state when they made medical marijuana legal? Right? So this was just a 1-0 variable. Okay. They also said, well, look, if for some reason, and I'll tell you the process they used. This is, what they did was they looked at this, spoiler alert, they saw that alcohol consumption actually went down. So then I said, well, look, what were some bad side effects of high alcohol consumption? Let's look at traffic fatalities. And they can even break that down specifically into those that involved alcohol. And say, okay, look, we know that maybe it decreased alcohol consumption, but does that also have a resulting impact on traffic fatalities? Okay. So they've kind of got two different Y variables. And here, I think they actually use two different measures of alcohol consumption. But really it just comes down to, if the year and the state had medical marijuana legalized, it was a 1. If not, it's a 0. Okay. So, sorry, I hate these masks. Sometimes I get beard hairs that come out and end up in my mouth. So probably too much information there, but we'll scroll all the way down, and they usually put their tables at the bottom. Right? So we're going to start with table 13. And kind of down here, they're indicating all of the different right-hand side or control variables they used. They just don't show them to you. So usually I've been showing you the output where it has every variable that we included. Well, here they kind of only showed you the coefficient that was on that medical marijuana being legalized variable. But the variables that they include, they call covariates, just a fancy word for all these other control variables that we included. So what were those? I think they had them in a table somewhere up here. So they had unemployment of the state, income measure, the average miles driven by people living in that state, whether or not marijuana was decriminalized, some graduated driver's license law. So there's just different policies they want to control for, seatbelt laws, whether or not a state had, excuse me, a kind of blood alcohol content threshold for DUIs of 0.08 or higher. I don't even know what this is. I'd have to hunt through this article. Some other policy they thought might kind of influence their results. Zero tolerance laws, what the tax level on beer was to try to control for, like, maybe there's price differences in alcohol across these states. And then whether or not their kind of maximum legal speed limit was above or below a certain value. Here, I think they chose 70. Right? So they've tried to control for a lot of other things. They also make sure that they mention, they didn't just include all these controls, they also include year and state fixed effects. So fixed effects, this was this idea of they include an indicator for every single year, left out 1 year to have that as the comparison group, and then an indicator for every single state, left one state out to have that as their comparison group. Okay. They also did this fancy thing that we don't even have to understand, but they included some like state-specific time trends. So they've really tried to account for a lot of things here. And even after controlling for all those other things, it looks like if a state had medical marijuana legalized, excuse me, relative to not, the number of drinks that people consumed actually went down. The number of drinks for, a male on average consumed went down by 1.5. The number of drinks for female went down by half. And that primarily this was being driven by young individuals, right? So each column here represents a separate regression. They ran this regression once for just males, right, and their number of drinks. Then another regression for just females, and their number of drinks is the Y variable. And then they ran it as the number of drinks for these different age categories. So what they found was the real strong impact is coming from when medical marijuana was legalized. There's a great reduction in the number of average drinks that this 20 to 29-year-old age group is having. So this would kind of provide some strong evidence that, at least for the 20 to 29-year-olds, right, these two goods are strong substitutes. When marijuana was legal and available, we saw the amount of alcohol consumed in this age group fall dramatically. Right? Now, the estimate is negative for all these other age groups as well. It's just that we can't quite say, we couldn't reject the null. We can't technically say it's different from zero. I think one of the issues here was, well, they have even number of age groups, so it shouldn't be an issue. But yeah, it's primarily being driven by young individuals. And you kind of see here, there's maybe some slight differences in gender, kind of how they view these things as substitutes. Now, they did a similar thing for binge drinking. Once again, they don't really pick up a lot of significance that anything is, we can't reject the null. The only one that was what? Female binge drinking looks like it goes down. But even though we can't say it's significant, most of these estimates are negative, right? And the one that is significant is in fact negative as well. Okay. So here we found some evidence that medical marijuana being legalized decreased alcohol consumption and that they're substitute goods. What's a little more interesting, and maybe from anecdotal experience, this doesn't shock me, is they also looked at state level beer, wine, and liquor sales. And what they found was medical marijuana being legalized had largely no statistically significant impact on liquor or wine sales, but that the reduction in alcohol consumption was really coming from the reduction in beer consumption. I forget exactly how they measured these sales. It was like per capita, but I don't remember how exactly. It was like per 1,000 people or something like that. So to translate these coefficients is a little bit tricky, but we can at least think about the story that's being told with the sign and the significance here. So medical marijuana being legalized looks like it's decreasing alcohol consumption. Okay. And there's a lot of other evidence out there that would suggest that as well. Okay. Excuse me. Any questions up to this point? Okay with this? So the next step they do is we go back to table 7. And they started out with a naive regression, no controls, and said, okay, if medical marijuana is legalized, what happens to the number of traffic fatalities? All right, so these are car accidents where a death is, a result. Well, it looks like if medical marijuana was legalized, that decreases the number of people who die in a traffic fatality by about 0.248. And I believe they put this variable in per 100,000 drivers. All right. So if we had the number of drivers in each state, we could kind of back out exactly how many people this saved. I did a little bit of a crude kind of back of the envelope to figure out, use some rough population numbers. And I think when we use that value of negative 0.09, that leads to something like in the United States that would save just under 1,000 lives. So we're talking, it's not the most substantial, but it's a pretty good amount from literally just a policy that legalizes marijuana. Right? There's a lot of other impacts of doing that as well, increased revenue for the state, all these other things. But here it's also going to be potentially saving almost 1,000 lives if we back that out. Now, as they add in more controls, that's kind of what they're doing, moving from column 1 to column 4. Each column represents a separate regression. So here they included nothing. Then they did those year and state kind of indicators. Then they included all their other controls. Then they did those state-specific time trends. And once they include all of their controls, we still see that it's decreasing the number of traffic fatalities, and it's significant at I think 1 star here represents 10%. So I think I might have failed to mention this. But when we're thinking about whether or not we can reject the null, generally when we have our own Excel output, we have the p-values, right? So a lot of times papers won't tell you the p-value, but they indicate it with stars. So I forgot to say this earlier, so maybe this makes a little more sense if we go back down and look at what we were talking about. So anytime I see 3 stars, that represents that coefficient, I could reject the null at the 99% confidence level. 2 stars, I could reject it at the 95% confidence level. 1 star, I could reject it only at the 90%. Okay? So I'm really looking for stars when I want to see, is there a significant effect? Can I reject the null for these different values? So if we go back, where was it? There we are. We could say with 90% confidence that medical marijuana being legalized decreases traffic fatalities here. And kind of the amount would be 0.09 per 100,000 drivers. Okay. So it's fairly interesting. Also, R squared, we're explaining 97% of the variation. So we're not going to be near as concerned about like an omitted variable here. There's very little that we haven't explained using all of these controls. Okay. They then break this down and say, well, look, there's no reason that this medical marijuana law would change traffic fatalities, or we can't imagine how it would impact traffic fatalities, except for kind of decreasing alcohol consumption. So they said, what happens to the number of fatalities that don't involve alcohol once we legalize marijuana? And what they found was it's a negative effect, but we really can't say it's different from 0 at any of our conventional benchmark values. However, for traffic fatalities where someone had a blood alcohol content over 0 and then a blood alcohol content of 0.1 or higher, that's really the traffic fatalities we're no longer seeing, right? That's where the greatest reduction was. Okay? So the interpretation would be like, once we have medical marijuana legalized, we see people are using less alcohol. And as a result, we're seeing fewer traffic fatalities where individuals had alcohol in their system, and even more greatly reducing that for when they had high amounts of alcohol in their system. Okay. So I forget, I think before it was using that 0.09, it saved 1,000 lives. So with 0.15, we could be saving even more here. Right? They then break it down even further and say, well, look, this is where they get a little bit fancy. And they say, okay, maybe it's not just in the year that, it's legal. Maybe these things take time. So instead of just including a 1-0 variable for was it legal, they start to break this up at a different time. So the first thing they do is they say, okay, look, here's an indicator for the year it became legal. Then an indicator for was it between 0 and 1 years it was legal. Then another indicator for has it been legal for 1 to 2 years, etc. Right? So they can pick up, is it medical marijuana being legal? Does it have any impact the year it happens? Because it might take some time to roll out, right? For there to be kind of stores that provide this service. And maybe 0 to 1, there still isn't a lot. They're not really that effective. They're not advertising well. But maybe over time, right, we actually see people starting to use this legal product. The system is now set up for it. And so maybe it takes a little bit of time. Right? They then also do this really neat thing, which is, well, just me using the word neat already says it probably isn't. But so we've got B3 here. We could also do, well, what if it was 0 to 1 years prior? Well, if I include indicators for any number of years prior to when medical marijuana became legal, hopefully I see no effect. It wasn't legal yet, right? So what we call this is kind of like a counterfactual or a falsification test, right? There's technically a slight difference between those two, but for the sake of the discussion here, they're both really similar. So that's what they did here. And what you see here is for those years before it became legal, nothing is significant, right? Even the year of the change, basically 0 impact. Right? 1 year after, or less than a year after, still, we're getting negative impacts here, but not quite significant. However, once we start to get further and further from when that law change took place, we then start to see these really large negative effects, right? So it looks like it might take some time for this legalization to like actually start having an effect, right? People to actually start substituting away from alcohol and then see this reduction in traffic fatalities. And here that was just two separate regressions for fatalities where there was any alcohol involved and fatalities where it was like extreme, right? 0.1 or higher, okay? And that's where we see the greatest effect. It looks like people aren't binge drinking to the level they were before. You know, I don't know. Maybe the argument is right. You can, you know, I don't have to drink as much to get in the headspace. I can use this marijuana as well as a little bit of alcohol, and you know, we see this reduction in these extremely kind of high blood alcohol content fatalities. Okay. Any questions over any of this? And I think the reference point here would be to like anything prior to any more than 3 years before medical marijuana. They then broke this down. There's not huge differences in the size of these estimates, but the only ones that we see with a p-value that's less than what 0.1 and less than 0.05 is that it's really reducing mainly traffic fatalities on the weekend and at night, which if we're thinking about alcohol use that leads to traffic fatalities, that kind of makes sense. There's not as much of a reduction for traffic fatalities during the week, during the day, right? I don't think that's, you know, that kind of would line up with the way that most individuals are probably kind of using alcohol and primarily on like weekends and at night when they're not working, right? So they also break it down by age, just kind of interesting. We can see here, where's the primary effect at? Well, it looks like it's for younger age groups, the older age groups, although still negative, we can't say that it's any different from zero based off of the fact that they're a little bit smaller. And then for really young individuals, it looks like there's not really a change there in traffic fatalities either. Okay, so it's primarily in this 20 to 50 year age range. It's reducing the traffic fatalities. And then they break it down, males and females. Looks like males are a little bit more sensitive, right? It's reducing traffic fatalities involving males a little bit more than it is with traffic fatalities with females. Okay. So I don't know, I thought it was kind of a fun example. It's pretty easy. Like this is, they don't do anything outside of these state-specific time trends. They don't do anything that's wildly different from what we've kind of talked about in class, right? They've haven't done any fancy what we call econometric techniques. They've really just used kind of this multiple linear regression to answer the question of whether or not this policy is having these kind of indirect impacts, where people are substituting away from alcohol, which is resulting in fewer traffic fatalities, specifically traffic fatalities that do involve alcohol. You know, you can do a lot of this. Like there's programs in the schools out there where it's literally just policy analysis, and a lot of it is running regressions similar to this. Now they have a few more advanced techniques so that we're guaranteeing that it's not just correlation, that it is in fact causal, but right, that's really all you're doing, right? You're kind of going to go through these different policies to see, was there a change in behavior after that policy as opposed to before? And all that is that 1-0 variable that identifies, was the policy enacted in this year or was it not? Any questions over anything there? Anything, any questions not related to anything we talked about, like anything with homework or the exams or anything like that? All right, so I'm going to ask you, yeah. So it's just going to be from where we left off in the last exam. So primarily two population stuff, where we compare sample means, we compare sample proportions, we did matched pairs, and then regression. So much smaller set of topics, I would say.
Is it still 20 questions?
I had it the other day. I think I ended up stopping it. I'm probably going to go back and touch on it. So I'll hold off until Monday to tell you exactly how many, but it's going to be a little bit more than 20, but not more than 25. I think I currently have it at 23, and I'm trying to decide if that's the 23 I have is good enough, or if I want to add one or two more. But yeah, right around that number. Did you have another question?
I was just going to ask the regression stuff.
Oh, so Good question. I would look at some of the practice exams to see what that looks like. But a lot of the times I copy and paste a picture of the Excel output. So like I give you the coefficients and I give you the p-values and then ask you questions about them. Yeah, that's a good question. You don't have to run the regressions, but you just have to know how to use the output, right, to answer different questions. Anything else? Yeah.
What day is it?
The exam? I forget this class. I think we're Friday, unfortunately. I've got 2 Friday, 1 Wednesday, 1 Thursday, so we'll see how bad my memory is. Yeah, so this one's kind of later slot on Friday. So I don't choose these. I wouldn't have chose this time, but this is what it is, right? I think related to that, if you have more than 2 exams in the same day, you can move one around. So if that ends up being the case for anyone, email me as soon as possible to set up an earlier date to take that exam. But otherwise, yeah, we'll be in class 2:15 to 4:15 on Friday of next week. Do you have a question?
Well, with regards to like the exam.
Yeah.
You said there are maybe a couple like
So it's gonna all be set up as, so I ended up deciding is to set up all as multiple choice. However, some of those multiple choice I feel like they read more as like, obviously like you've got 4 options, but they read more as a little bit short answer. Yeah, but it shouldn't be, it's nothing like you're writing out sentences or paragraphs like the.
In particular, like rounding, is there gonna be any sort of rounding issue? Like disconnect or something?
There's some, yeah. Which is like I had to put out I've talked to a couple people individually. I might end up, I think it's for question 6. I'm probably just going to end up giving everyone credit for it because depending on the random numbers you get, the rounding issues are resulting in you not getting it correct.
7, the one that you said you have to do like percent.
You had to move it 2 places. Yep, that was number 7. So I had that announcement out there. Or a little bit off.
Looks like looked at it.
Okay. Shoot me an email. I'll take a look at it too. But yeah, it shouldn't be nothing on the exam. Am I ever going to have where there's 2 answers where your rounding would lead you to go with one versus the other?
Yeah, I was just gonna ask about that. So I feel like you can intermediate calculations with those that are adding the 2 decimal places.
Yeah. So usually, like I said, I want on the homework, it usually tells you how many decimals to round your intermediate values to. On the exam, it's never going to be where if you round, like you're going to get 2.23. The answer is 2.24, but I'm not going to put both of those on there to like so that you go with one or the other. Like everything, the answers will be different enough to where like even if you round it a little bit off and you're 100th point off, you're going to be able to identify, well, this is going to be the correct answer. Any other questions there? So I got one thing to ask of you today. I was hoping more people showed up. I know, I'm sure you hate getting inundated with the emails. I do as well. But if anyone's watching this on YouTube, I'll leave this recording going. I would greatly appreciate it if before you leave today, you use your phone or your computer to do the online evaluations. I get hounded about making sure a lot of you do it. And so I'm mentioning it. I think it's open until the end of the day on Monday. But it really helps me out. It helps out the College of Business to get as many of those kind of student evaluations back as possible. So, if you don't mind taking a little bit of time, do on your phone, computer, I'm gonna kind of pack up and head out. Or, if you got somewhere to be, if you please would do that kind of after the fact, I'd greatly appreciate that. Okay? Even if, you have some criticism and harshness, either way, it's beneficial to me. Okay.